Hi everyone, today we're going to do some rounding exercises and we'll start by looking at what the decimal system is telling us and then go from there. So the origin of the decimal system was somewhere between 3rd and 4th century, and it was found first in Hindu texts, and then it was drawn by the Greeks, I believe, through Latin script until we had the digits that we use today, 0 to 9. Earlier systems not based on 10 also used concepts similar to decimals to mean parts of a whole. Our system, the decimal system, is called a base 10 system because it has 10 digits, 0 to 9. Other systems exist, such as the binary system with base 2, so that would be digits 0 to 1, and hexadecimals, which is base 16, with digits 0 to 9 and A to F. Other systems of counting exist that don't have a concept of decimals, such as Roman numerals. There's no idea of parts of a whole with that. Now, with our system, place value has a big part to play. So where a digit exists in a number indicates its magnitude. So a number to this left would be bigger, a number to the right would be much smaller. A number to the left of the decimal point is a whole number. A number to the right of the decimal point is parts of a whole. Now, typically in primary we deal a lot with whole numbers, don't deal so much with parts of a whole, but in high school we increasingly have a look at this through fractions and algebraic treatment of numbers. So today we're looking at rounding. So rounding is looking at a number and changing its level of precision. So say we had the number 123 and we weren't interested in 123, we just needed to know if it was closer to 120 or closer to 130. Well, we could look at our number line here and position 123, and visually we can see that it's closer to 120. But if we zoomed in a bit further and say we want to know, is it closer to 120 or 125, we'll put 123 on, and visually we can see that's closer to 125. This case is a bit more difficult. We've got 123.4 and 123.5, and we want to know, is it closer to is 123.45 closer to 123.4 or 123.5? Well, 123.45 would be midway, and if something is exactly midway, we would round the number up and say it's closer to the higher number. Here's another case. We've got 123.45 and 123.46, and is 123.456 closer to this one or that one? Well, 45 would be midway, so anything after 45, 450, would of course be rounded up. Now, in each case, we're looking for a different level of precision. In this case, we're looking to the nearest whole number. In this case, we're looking to the nearest 10. In this case, we're looking to the nearest 5, and they're both whole numbers. In this case, we're looking to the nearest, we're looking to 1 decimal place. In this case, we're looking to 2 decimal places. And typically in all of these cases, we look to the digit that indicates to us which one is closer. So in this case, it would be this digit here, this digit here, this digit here, and this digit here. It's typically one place after the digit that we're looking at. And we'll give that a name. So that digit that we want to round towards, so whether it's 1 decimal place, 2 decimal places, 3 decimal places, is called the least significant digit, because it's the digit that has the smallest value in the number that we're seeking. So if we wanted it to 1 decimal place, we're looking at that digit there. Should it be 4 or should it be 5? In this case, this digit here indicates that it should be a 5. But we'll look at that in more detail now. The easiest way to do rounding is just to think, what number is it closest to for the level of precision that we're looking at. So in this case, it wants the nearest whole number. So we want to know, should this number be a 3 or should it be a 4? Those are the only two choices. And to do that, we look at the next digit. And does that digit indicate to us that this whole number is closer to 123 or 124? And one way to think about it is to put a 0 here No, let's not do that right now. Let's just think about it. 123.4, is that closer to 123 or 124? And obviously that's closer to 123. There is another way of thinking about it, and I'll introduce it later, but right now, without going through a little bit more maths, it might be a bit too early. Okay, so this time we're going to go to one decimal place. Here's our least significant digit. We'll look to the next one. With 123.4, 5, is that going to be closer to 123.4 or 123.5? It's often easier to put the 0 on the end. Here it is where we introduce it. And say, is 45 closer to 50 or is it closer to 40? It's closer to 50 because that's halfway in between, and if it's halfway in between, we always go higher. So we would say that it's 123.5 is the rounded answer. Putting this extra 0 on the end can help because you think 45, 40, 50 rather than 0.4, 0.45, 0.4 and 0.5. Okay, 123.45 to 2 decimal places. That's the least significant digit. So is 459 closer to 450 or 460? Obviously 459 is closer to 460. So we would say 123.459 is close to 123.46. To 3 decimal places, 123.459, there's the 3rd decimal place. So now we're going to look at those 4 decimal places. Is 4599 closer to 4600 or 4590? Obviously 4600. So we would just say that it's close to 123.460. Now I can see where confusion would come between these two numbers here and this one here. It's just that the 0 can help us when we're comparing this number to find out which one's close. Then when you finish, you just take that digit off when you write your answer. Okay, 4 decimal places. So now we're looking at 45922, look at the digit after it. Is that closer to this number? So is this number here closer to this one or that one? Obviously it's closer to 45,990 than 46,000. So we would write the answer as 123.4599. So the main thing is to check that your answer always has the desired number of digits, and then to use the digit after the least significant digit to indicate to you whether you should round up or not. So we just used this algorithm, but let's write it formally and then forget about it. So if we were going to round a number, we'll first identify the least significant digit and the next digit after the least significant digit. If the digit after the least significant digit is 5 to 9 and the least significant digit is not 9, then increase the least significant digit by 1. If the digit after the least significant digit is 5 to 9 and the least significant digit is a 9, then let the least significant digit be a 0. Then, if the digit to that isn't equal to 9, increase the previous digit. If it is equal to a 9, let that digit be 0 and then repeat. And then remove the digits after the least significant digit. Okay, so that's the algorithm. Let's see if we can do it. So look at the 3. The next digit is a 4. That's not 5 or less. Just remove all of this junk. And thus you get 123. The next one, we want to round to 1 decimal place, so the least significant digit is going to be this 4. Look at the next digit. Is it 5 or higher? If it is, increase this digit and get rid of the rest. That's what we've done here. Here, looking at the 2nd decimal place now, so that's the least significant digit. That's the digit after it. It's between 5 and 9, well, including 5 and 9. So just increase the least significant digit and truncate the rest. So that becomes 6. Get rid of all of that. So we've done that here. 3rd decimal place. All right, here's the 3rd decimal place here. The digit after it indicates that we have to increase the previous digit. So we'll increase that to 6, make that 0, and truncate the rest. It's down to 3 digits. So 4599, 4599 is closer to 460, make it 460. Okay, 4 decimal places. That's now the least significant digit. Look at the next digit. That's a 2, that's fine. Truncate it off, get rid of it, leave it as 4599. Right, now many errors are made with this. And it's easy to see why, because this algorithm is quite complicated. And we ask students to either think like this or think like this, and sometimes don't appreciate that there's a lot of steps involved. So, with that in mind, I thought I'd better do a whole heap of them. 1 decimal place, highlight the least significant digit, look at the one after it. It's between 0 and 4, so get rid of all the extra digits. Done. 1 decimal place, here's a 4, the next digit is 0. Great, get rid of all the digits. Done. 2nd decimal place, here's the significant digit, the least significant digit. The one after it's bigger than 4, is between 5 and 9. So that means we have to increase this digit and then truncate. So increase that to a 5 and then get rid of the rest. Round it. In this case, it's a 5 again. Look at the next digit. It's a 6. That tells us to increase this digit and then get rid of everything. So what we've done, increase, get rid of the rest of the digits. 3 decimal places. There's the 3rd decimal place. Look at the next digit. That says increase this digit. Make it 6.773, which we've done, and get rid of the 8. 1 decimal place. That's a 4. That's a 4. Tells us just to truncate. Oh, that's not right, is it? That's too many decimal places. Someone didn't check their answers. That'd be me. 7, 8. That's bigger than 4. It's 5 or higher. So increase that, which we've done. Get rid of the rest. 1 decimal place. That's higher than that. If we increase 9, that becomes 0. That means we have to increase the previous digit. So 6.95 is closer to 7 than it is to 6.9. Get rid of the rest. Done. Round to the nearest whole number. No decimal places. Okay, so here's the whole numbers. Look at the next digit. Is 5.9 going to be closer to 5.9 or 6? Well, I'd say it's going to be closer to 6. This digit here is a 5, 6, 7, 8, or 9. If that's the case, increase the previous number and then truncate, which we have done. This hasn't got a number to look at, so it's already 2 decimal places. We don't have to do anything. 4.331. Look at the next digit. It's a 3. Just truncate. Bye-bye. 4.3. 3.23. The next digit is a 3. Just truncate. No need to increase it. 2.52. Next digit is a 4. No need to increase it. Get rid of that. 390. Okay, in this case, that's an 8. That tells us we have to increase the least significant digit. So it becomes a 1. Truncate the rest. 1 decimal place, that's the 6 here. Look at the next digit, truncate. 2.20, 2 is less than 5, truncate, get rid of the rest. 0.37, 7 is 5 or bigger, so the least significant digit has to increase, which we've done, get rid of the rest. 2.861, the 6 indicates that we have to increase, make that 2.9, get rid of the rest, done. 9.16, the 6 is bigger, is 5 or higher. Increase the least significant digit to 2, get rid of the rest. 9.67, 7 is 5 or higher. Increase the least significant digit, which we did, get rid of the rest. Last but not least, 9, the least significant digit is 2. The digit after it's a 9, that's 5 or higher. Increase the least significant digit, which we've done, and delete the rest. So once you've seen that many examples, it's sort of, you start to get the idea of what it is to do and what this algorithm here is trying to teach you. But it's much easier to learn it from seeing it in action, I think, than trying to figure out a process like this formally, or to be taught an algorithm to follow, because the algorithm itself is quite detailed. If I was going to program this, I would need to do something like that. Okay, so I hope that helps, and I'll see you in the next number video. Thank you, everyone.